Okay, hello everyone and welcome to today's Green Business Fund technical webinar. This one is the technical webinar for HVAC systems. So I'm your presenter today. My name is David Tobin. I'm a chartered engineer and energy consultant with the Carbon Trust. I specialise in conducting energy audits, so I've seen a lot of HVAC systems of various types and quality of control, and hopefully better talk you through some key energy saving recommendations for these types of systems through this presentation. So here is a quick run through of the agenda for today. So we're going to look at HVAC systems and why they're important, run through the typical HVAC systems that we see, some typical energy saving opportunities for those systems, a few other considerations, then some case studies, and then a few more details about the Green Business Fund. Now this presentation we've aimed at all levels of understanding, so I'll be speaking in quite broad terms about HVAC. But if you do want any information about any of the particular systems that we cover, we will be running more webinars as part of the Green Business Fund, so please do feed that back, and that may help us construct future webinars. So first, a bit of an introduction, an overview of the Carbon Trust for those of you that are less familiar. We've been around since 2001, and we're a not-for-profit organisation, and we're mission-driven to accelerate to a sustainable low-carbon economy. And a key thing is that we're independent experts on carbon reduction. Our services that we provide fall into three key baskets, so advice, footprinting, and technology. And the Green Business Fund really falls into our advice offering, where we support businesses around identifying energy-saving opportunities. So a quick run through the aims of the webinar. Hopefully this is what you will take from today's presentation. I'll give you an overview of how to improve your understanding of the typical types of HVAC system. We'll develop an understanding of how important controls and processes or new technologies can deliver cost-effective energy saving, and that's really where we do focus this webinar, is on identifying those cost-effective energy saving measures. We'll cover the importance of good maintenance and how that can help also reduce your energy consumption, and we'll go through some case studies to illustrate where HVAC systems have been optimized and how the Green Business Fund can help. But before we do go into that, and just to really go back to the a point about cost-effective energy savings, it's interesting to note that your controls can have a massive impact on your energy consumption and reducing it. So, as a rule of thumb, for every 1 degree C of overheating, heating costs can rise by about 8%. Now, that exact figure may vary based on your heating system, but as a demonstration, this illustrates the importance of considering effective control and management of your systems as a priority before investing in system upgrades. So we'll move on to what are the typical HVAC systems that we see, and what is really the definition of HVAC. So just to make sure everyone is on the same understanding and you're all on the right webinar. HVAC is heating, ventilation, and air conditioning systems, and they control the temperature and humidity and quality of air in buildings to a set of chosen conditions. To achieve this, the system needs to transfer heat and moisture in and out of the air, as well as control the level of air pollutants either by directly removing them or by diluting them to acceptable levels. Now, if a HVAC system gets all of these things right, then your building occupants shouldn't really notice a good HVAC system, and neither should any processes that are there to be managed by the HVAC system. So why is HVAC important? Well, essentially for the places where we work and live, we need a safe and healthy, comfortable environment. We need heating for losses from the building and through ventilation, through fabric, or through other places such as it getting trapped at high level in high ceiling spaces. We need cooling to balance out heat gains from the sun, people, equipment, such as IT or process machinery, and the need for cooling may well increase as we see global temperatures rise. And ventilation, we need to maintain a healthy and alert building occupants. and is important from a carbon emissions perspective, as nearly 60% of CO2 emissions from public commercial buildings can be attributed to HVAC systems, so it's substantial. Moving on to what are the typical HVAC systems that we see when we go out on site. And we'll start with heating systems because it's something that nearly every site will have in the UK. Most common are wet systems with fossil fuel fired boilers, often with just distribution pipe work to local radiators. They can be varying sizes based on whatever building you occupy, but these are the most common ones we see. Warm air heaters, again, these are often fossil fuel fired, and they're often found blowing warm air into factories and warehouse type spaces. Radiant heaters, these can be gas or electric, again often found in factory, warehouse type spaces, but this time providing direct heat down to occupants rather than to the general space, as with warm air heaters. Electric direct or electric night storage heaters, they're often installed when there's no mains gas available or as a cost-effective alternative to a wet system. Night storage heaters taking advantage of the lower overnight electricity costs to charge and then release heat over the day. And also heat pumps, we'd class these within heating systems. These often provide both cooling and heating and are mainly found in office type locations. What do we include when we speak about ventilation, the V in HVAC? Opening windows, natural ventilation is ventilation, and particularly at times of the year with moderate temperatures, this is a free way to ventilate your building and is a very valid way of saving energy rather than cooling. One of the more basic arrangements for mechanical ventilation is to have individual direct supply fans to push air into the building, with exhaust or extract fans to take out. That's more simplified mechanical ventilation systems. In larger buildings, you may see a packaged air handling unit, which can both supply and extract air, but will also often contain coils to heat or cool the airflow before it enters the occupied space. So moving on to common types of air conditioning system, and what do we mean when we talk about these? There's a few common arrangements we often see. The most common, I would say, is the localized refrigerant-based system, where air is treated locally by an internal unit or units. You can see the cassettes there, very common outside office blocks, normally supplying a single internal unit or multiple units for the larger cassettes. You can see in the image on the left there. Large office type accommodation may have all air treated, heated or cooled at the air handling unit in the plant room before it is distributed through the ductwork. These are more what we call centralized systems, and then you may get partially centralized systems, which can be a mix of the two, treating some air at the plant room to distribute and treating some air locally via fan coil units or local radiators, etc. And these diagrams just give a bit more of an illustration of the descriptions above if the images you weren't familiar with. Again, localized systems being the most common, with larger offices tending to have the centralized or partially centralized systems. Something that often gets overlooked in HVAC is hot water. It's often left out of the HVAC conversation, but if you operate a hotel or a leisure facility, for example, then hot water could add a considerable year-round baseload to your heating demand. So it is important to consider this when looking at your HVAC system holistically. Hot water can be heated by central heating via a cylinder or combi boiler, but it can also be by a separate dedicated system, such as direct-fired gas heaters or electric point-of-use units. And we typically find that dedicated systems often prove to be the most efficient arrangement, allowing central boiler plant to be shut down during summer months when there is no heating demand. So now we know what we're talking about when we refer to HVAC systems. Let's have a look at what we're really here to talk about, and the typical energy saving opportunities we see with those systems. And up to this point, we've just to cover the various elements of HVAC. We have looked at the systems separately, but for energy saving, really, it's better to look at the system as a whole and how the different systems relate to one another for energy savings to be most effective. Typically, they're the key actions and techniques to achieve energy saving within HVAC systems come within these three quite simple hierarchy of actions that we have to take. So first, can it be switched off when it's not needed? Secondly, could controls be utilized better or improved? And then look for energy efficient, energy technology listed equipment for upgrades. We'll discuss the energy technology list a bit later on, but that's typically the order in which we look in, because obviously the top two can often be very cost effective. Equipment upgrades can be more cost intensive. So one way of reducing your energy consumption with the HVAC systems is to reduce the need. And before we look at how we do that with individual systems, considering the HVAC system as a whole, you can make quite simple improvements before looking to invest. So you can reduce overheating and the requirement for cooling with effective shading, so positioning heat emitting equipment such as printers in separate rooms, and have highly efficient LED lighting, which gives off much less heat than standard fluorescence, again reducing your cooling demand. You can open windows as discussed before switching on cooling. Sorry. And where you have varying heating or cooling demands across the side, make sure your system is flexible so that you only heat where required through effective zonal control. Daylight blinds can be effective at redirecting sunlight onto ceilings to continue to allow light into the building, but without having excessive heat gain, which again requires cooling. Or again, you can look at night cooling as a means of allowing cool air into the building overnight to lower the temperature at the start of the day. This is particularly effective in office buildings, just to reduce the cooling demand once the office building gets started. An interesting fact in the orange box there is that if you're looking to go from a standard heating and natural ventilation system within your office to a fully air-conditioned office, it's likely to cost in the region of 30% more to run. Now, this obviously isn't. This is a rule of thumb guidance. It's very much dependent on the systems you have. But typically, even though air conditioning systems can be very efficient and effective, you will be using them more than likely during the summer to provide cooling, whereas you wouldn't necessarily with a standard heating system and natural ventilation system. Hence the higher general overall costs to run them. Again, so the key consideration for HVAC systems is understanding your controls. You should really be asking yourselves, do you know in detail the operating periods and temperatures for all of your HVAC systems? So your time controls and your temperature controls. And when was the last time you checked them? If you can't answer yourself with the exact set points of the system, then it's likely that the controls perhaps have slipped from optimal. And just because there are no complaints within the building doesn't mean that necessarily the controls are optimized. For an office building I'm working with currently, is only by analyzing detailed metering data for the natural gas consumption that it became evident that heating systems are starting up around 3:30 a.m. every day, which is well in advance of when was needed to achieve optimal internal temperatures, and would have gone unnoticed because the building felt comfortable to occupants had that metering data not been analysed. So if you're not sure, check your startup and close down times, check your temperature set points, and make sure that the system is fully optimised. There are controls that can help do that and do these things automatically. And we'll start by looking at heating systems. As I say, that's perhaps the most common of the HVAC systems that we come across. And typically, heating systems can account for more than 40% of energy use in a business, so it's a very valid place to start. In terms of simple control for heating systems, particularly gas-fired wet systems, the most common ones we see. Thermostats and standard timers are one of the key aspects of controlling a heating system. You should really be thinking about where your thermostats are located. If they are near drafts or external openings in direct sunlight or near internal heat sources such as printers or process machinery, then they will not be reporting accurately on ambient conditions. The image shown here is a boiler controller with built-in thermostat, but this logic applies to thermostat control of all kinds for heating and AC systems. A common one we often see for fan heaters in warehouses is locating thermostatic controllers near large roller shutter doors, which can clearly hamper the recording of internal temperatures if it's just recording the external conditions when the door is open. Thermostatic radiator valves don't control the boiler. They reduce the flow of water through the radiator, which they're fitted to when the temperature goes above a certain setting. So you want to set them to the level you want in the room. Lower settings use less energy, so it'll save you money. Be careful when using radiator covers. TRVs sense air temperature around them and control the flow rate depending on what level they're set at. So having a cover over the radiator means that the TRV is enclosed, which is likely to make it feel the room temperature warmer than it actually is. But these are effective ways of controlling a basic heating system locally and centrally. A bit more detail on heating controls. Systems with older timers are generally worth upgrading. The upgrades can very quickly pay for themselves. This can often include a weather compensator that will automatically regulate heating output based on external temperatures, and an optimized start control, which will learn how quickly it takes your building to heat up to reach the desired temperatures, to start heating at the optimal time to reduce the runtime outside of operational hours. You can also run that at the other end of the day and shut down the building, or shut down the heating, so that the building maintains its temperature for the optimal hours for which the building is occupied. Both heating and cooling is quite common, particularly in office spaces, as heating is needed to warm the space at the start of the day, but then cooling comes in once the office starts to fill up with people using IT equipment which emits heat. So make sure they don't clash. Make sure your heating and cooling systems operate on with an effective what we call dead band of temperatures. For instance, this gives guidance that below heating should not come on once internal temperatures exceed 19 degrees, and cooling should not come on until internal temperatures exceed 24 degrees. Now, between these two temperatures, no heating or cooling takes place, and you would be surprised just how often the space within your building will remain between those temperatures without any external or artificial heating and cooling. For boilers, just give a bit of guidance here on what controls you should look to have depending on your boiler size. So for smaller boilers, up to 50 kilowatts, we typically expect as a minimum a boiler interlock with a timer or thermostat. But if you're looking for a good standard, look to implement the optimization and direct weather compensation we discussed on the previous slide, just to optimize the system and its control. For boilers greater than 50 kilowatts, you will likely have a pair of boilers operating in tandem, so a sequence control is also included as a minimum with a boiler interlock. Good standard, again, implementing the optimization, direct weather compensation, but your system, particularly when we start getting into the hundreds of kilowatts, may start to walk into the territory of actually being able to benefit from a building energy management system, which will closely control all of the elements of your heating system, not just a central boiler plant with local sensors. Often that can lead to significant savings, and as an example, through the Green Business Fund, a firm of solicitors that we've been working with in Leamington Spa, say 15% on the heating bills just by optimizing the system with compensated heating control. So it can be a significant factor in the way your system performs. For heating systems, moving on to maintenance, which is key to their efficiency. You should really be looking to service your gas boiler once a year and oil boilers twice a year. And make sure the maintenance provider is checking and reporting the efficiency to you. Good maintenance can easily save in excess of 10% of your fuel consumption. The example diagram here shows clean burn at the top versus dirty burn at the bottom. So the highly luminous flame is indicative of carbon particles. So it's burning too rich and result in substantial reduction in energy efficiency. And servicing boilers should help avoid these, again, relatively hidden inefficiencies. Insulation. It's very common that we see this. You should really, a question I would ask is, when you walk into your boiler room, is it hot, hotter than the other rooms around it? And often we find that this is yes, and it's due to poor insulation. And insulation is critical to ensure heat is only admitted in areas where you need it and not lost to plant areas or service spaces. And you should ensure that all valves and pipework joints are insulated, as an uninsulated valve can admit as much heat as around a metre of pipework of the same diameter. So it's something we see very commonly, just heat being wasted into boiler rooms and plant spaces, service spaces, just because insulation hasn't been upgraded. And again, this isn't something you would necessarily see as an inefficiency as a building user. If you are going to look to invest in plant upgrades for heating systems, there are many ways to do this, but these are some of the more common ways that we see and recommend as we go around and perform energy audits on buildings. So boilers used for heating have become much more efficient than some of their older counterparts, and this is largely due to stricter building regulations. And these regulations set minimum standards for new and replacement boilers. However, if you opt for an even higher level of efficiency, you could cut your energy bills by up to 30%. Condensing boilers are the most efficient designs that you can get, and typically all modern boilers are condensing. These use large heat exchangers to extract as much heat as possible from the waste flue gases. Typical saving, as stated, is 10 to 30%, and typical return on investment, because it's relatively high capital expenditure, you're looking at around 5 years as a ballpark. The next recommendation is moving from warm air heaters to radiant heaters. Warm air heaters tend to heat the whole building. These are particularly applicable in large warehouse manufacturing type sites, when you actually potentially only need to heat a small area where you have occupants. With radiant heaters, you can get fast, efficient heat and often recoup your cost in less than a year on the right site. But you do need to have the right site. You do need to have your operatives working in quite a concentrated area in order not to heat the whole space. If you've got people walking around the whole factory site, then often you do require warm air heaters, because people aren't often contained to one space. But if you do only require heat to one limited space within your factory, then radiant heaters can provide a means of reducing your energy consumption quite substantially. Something we often see in again, warehouse or manufacturing type spaces where you have high ceilings is that warm air rises and heat is lost through the roof, which is trapped at high level. And destratification fans can be an effective way to blow warm air back down to ground level where it is needed. That warm air is picked up by your local thermostats, and it can save you up to 20% on your energy bills. And typical return on investment we see for these types of systems is around the 4-year mark. So moving on to ventilation systems. So ideally with ventilation systems, where you can use natural ventilation because it's free. But if you are looking to use mechanical ventilation, make sure it's effectively sized and you're not overly ventilating the building. So avoid excessive airflow. 8 litres per second per person is sufficient for most office spaces. Some situations do require higher flow rates in toilets, etc. But multiply the number of people you have by that figure, and then compare that to the fan specification in your O&Ms or the operation and maintenance manuals, or with your maintenance team. And there may be scope to reduce the airflow rate to your building and reduce the energy consumption of your fan systems. Review time settings. Again, this is something we've mentioned with heating. Quite often see ventilation systems running out of hours, running for longer periods than necessary, so check that you have effective time control. And there are various ways which you can modulate the flow rate of the system based on the demand. One way of doing that is occupancy or zonal control via motion sensors. You can sense internal air quality via CO2 sensors and modulate the airflow into the building based on that demand. And also on exhaust systems, you can use dampers to close off areas or processes which are not operational and modulate the airflow based on demand. Varying fan speed. You need a variable speed drive to vary the motor, to vary the speed that the fan is operating at. It needs to be paired with suitable controls, but it can be very effective, as due to fan motor laws, if you reduce the fan speed by around 20%, it results in an energy saving around 50% of the motor, which is obviously substantial for a not huge reduction in your airflow. So it's something very worth considering, and I'd encourage you, if you do want more details on motors and drives, to watch our GBF webinar on motors and drives, which will give you more details about implementing variable speed drives on motors and fans, and how that can result in substantial energy savings. Maintenance is again critical for ventilation systems. Typically, the easier you can make it for air to flow around the ventilation system, the less the fan has to work to provide effective ventilation. So it should be part of standard maintenance to check filters and intakes regularly. Pressure gauges on air handling units will indicate if the filter is heavily blocked, and you can often improve efficiency by up to 60% if the system is particularly clogged. Air intakes will often be external, sometimes in challenging positions, but it is worth reviewing. I've seen some quite poor examples of maintenance of these types of systems where there are substantial obstacles in the path of the air, hampering the ability of the ventilation system to push air around the building. So it's very worth checking your air intakes and filters where you can. If you are looking to upgrade your ventilation systems, I've given a couple of examples here of ways in which we have seen and recommended recommendations to be made. The first example shows at the top shows a kitchen extract fan, which had its motors upgraded to a higher efficiency alternative, but its configuration had been changed to reduce friction losses from the existing belt and pulley arrangement that can be seen in the image, and to a direct drive system to reduce those friction losses, so the motor is directly connected to the fan rather than via a belt and pulley. And we also provided or recommended they install a kitchen air quality control system. This worked in conjunction with the existing inverter variable speed drive controls to modulate the speed of the fan based on the internal air quality in the kitchen. This particular installation reduced the energy costs by £1,800 per annum, the return investment of just 1.6 years. So fantastic investment and saving there with relatively straightforward measures. The bottom example there is replacing a standard centrifugal belt and pulley fan in an air handling unit with a purpose-designed free spinning, high efficiency direct drive, electrically commutated or EC plug fan, which saved around 30% of the fan energy costs. In this example case, the manufacturing site in Telford was able to save £2,800 per annum with a return on investment of 3.8 years. If you have long run hours, the payback can be even quicker, just because the fans are saving for a longer period of time. If you don't have the technical background and you're not sure where to identify these savings, then you can consider applying for a Carbon Trust Green Business Fund Opportunity Assessment, which I'll discuss in more detail later. So you can have a technical expert come to your site to help identify these opportunity savings if it's something that you don't feel comfortable with identifying yourself. Again, I'll touch on that a bit later on. And AC, again, we're going to start with controls because this is, again, the easiest way to and most cost-effective way to reduce energy consumption. As with other systems, check timers, make sure they're not running outside of operating hours. Check your thermostatic controls. Cooling shouldn't really be required in offices unless temperatures exceed 24 degrees Celsius. You can negotiate that with your office staff, but that is our guidance. And make sure thermostatic controllers are not located near any heat sources, printers, direct sunlight, radiators, etc. Server rooms are a common thing we see with server rooms is that they are overcooled, and common guidance we give is that there is no adverse effect to your IT equipment with temperatures up to 27 degrees C. So don't overcool server rooms. This can be a challenging battle with your IT teams, but it is worth it in the end, as I'll show on the next slide. And then there are cooling systems that can utilize free cooling when it's cold enough outside, and they will reduce the condensing temperatures to reduce the load on the energy-intensive refrigeration compressors in the external plant, and function with effectively free cooling. But your system needs to be capable of this. Please do consider these two myths that we've provided here. One is that if you leave air conditioning systems on overnight, they don't have to bring up or have a heavy load of temperature change in the morning. This will save energy. This is not true. You're much better in a vast majority of cases to be running your system when you are in the office, not overnight. You have a set back temperatures, certainly, but certainly don't run the system as a fully occupied office or any building during the night. Another common myth is that you turn down the thermostats as low as they can go so it cools the building more quickly. This is not true again. Again, the building will cool at the same rate. It will just overshoot that final temperature and overcool the building. And again, both of these are energy management and staff engagement are needed to really implement these effectively. But certainly, set your building to the correct temperature and run your air conditioning systems for the hours you're in the building, not any longer. Just to reiterate the point for IT server rooms, the guidance temperatures that are given here are from ASHRAE, so the American Society for Heating, Refrigeration and Air Conditioning Engineers. And as you can see, in this particular example, this PR company was operating the server room at 21 degrees C, but incrementally changing the temperature towards 27 degrees C reached a 10% saving worth over £1,000 per annum. So it's worth having that discussion with your IT teams to try and increase the temperature of your server rooms. And as a rule of thumb, every 1 degree C increase in cooling temperature set point typically delivers a 2 to 4% reduction in energy consumption. So worthwhile discussing, and it's worth the battle with IT teams to get that changed if you can, because it's quite an easy energy saving. Maintenance of AC systems is again essential for efficient operation. Internal evaporators and external condensers are effectively transferring thermal energy from inside to outside when in cooling mode. So if they have to work harder to blow air over the coils to gather or reject heat due to blockages on fins or filters, then this requires more energy within the system. And again, roughly 2 to 4% saving per 1 degree C in condensing temperature. So if it's having to increase that condensing temperature, then it has to work harder and use more energy. So clean and remove all blockages where you can, internally and externally. Some examples there of blockages that we commonly see with external condensers with plant or other debris outside in plant areas. Insulation, as with heating, is key, and it's often very visible in cooling systems. If you have cracked pipework, you can get, often due to the cold temperature of refrigerant, you can get frost buildup. And there's this example here, notes. Many chilled water systems operate with flow temperatures of 7 degrees C and return temperatures of 12 degrees C. So if the total heat gain through uninsulated pipework is 0.75 degrees C, the system will have lost 15% of its cooling capacity. And that's purely down to poor insulation, not any load on the system. So, if deterioration, in this instance, the energy loss is 15%, but if the deterioration of insulation is severe, losses can be much more significant. So it's well worth insulating your pipework to a high standard to minimize your losses and reduce the load on your cooling plant. If you are looking at technology upgrades, AC systems often tend to be less well understood than other HVAC systems unless you work on them regularly. So I'd recommend taking specialist advice unless you are familiar with the technologies and efficiency upgrades possible. Some options may include head pressure controls, which reduce the external condensing temperatures and hence the compressor load when it's cooler outside. Again, a 2 to 4% saving with every 1 degree C drop in condensing temperature. In the UK, we have a climate which we have a high number of hours where external temperatures are cool enough for free heat rejection. So free cooling systems can often maximize the benefit of this by utilizing these external cold temperatures to reject heat without the need for temperature elevation by the compressor in the cooling system. So again, that can be one way of improving the efficiency in investing in upgrades. Another consideration is that cooling systems essentially reject heat from a building, and this low-grade heat can be recovered for use in preheating hot water, for example, so you can recover this heat that's rejected. This particular example that we've given here had new condenser controls implemented with a 30% saving over £15,000 per annum at this particular London retail store. So again, utilising effective control and plant upgrades to make considerable energy savings on that particular site. But again, not straightforward systems, and often not well understood. So if you do wish to avail of an opportunity assessment from the Carbon Trust Green Business Fund, then an expert can be sent to your site and review where you have potential to save with these systems. Some other considerations, pumps. So heating and cooling systems rely heavily on pumps to circulate water. We often see them running 24/7 when not required, so check heating demands. So check your timer set points. Half-hourly data energy consumption can be useful for analysing where pumps are running outside of operational hours. You can also do effective life cycle costing when purchasing a pump. A lot of people don't do this. It's well worth, as this case study shows here, investing in higher efficiency pumps, as they'll often pay back multiple times during the life of the pump. This particular pump, for an extra, when purchasing a pump, an extra expenditure of £250 pays back £7,000 over the lifetime of the pump just by purchasing the higher efficiency alternative. So it's a very worthwhile investment. Flow rates, as with fans, can modulate based on demand, and variable speed inverter drives with effective control can dramatically cut the running costs of a water pumping system. Again, I would encourage you to watch the Motors and Drives webinar for further information on how variable speed drives can be implemented and affect energy savings within your heating system. And then a quick recap of some of the key points. So for heating, turn it down. Every 1 degree C, 8% energy saving. Upgrade to higher efficiency boilers could save 30%, and destratification fans to push air to a low level within high ceiling spaces can save 20%. Ventilation, high efficiency motors can save 5%. Effective control of the fans via airflow modulation or through upgrading to higher efficiency electrically commutated EC fans can save 30%. Timer settings, if they're running out of hours, they're running overnight, you can cut their energy consumption by half very quickly. Air conditioning, as with heating, effective temperature control, variable speed drives on your compressors within the refrigeration system to modulate external condensing temperatures, and investing in free cooling units if you are undertaking major plant upgrades. So we'll go through a few case studies that we've had through the Green Business Fund. This first one is for implementing heating controls of a manufacturer and installer of bespoke windows and doors. With about 180 staff based in Lancashire. This web-enabled heating control system with optimized stop-start programming and effective measurement of ambient external temperatures and internal temperatures substantially reduced their energy requirements for their heating system, saving them nearly £5,000 a year, and again with a contribution from the Green Business Fund to support that investment in the system. This precision engineering company, located in Derby, upgraded from an existing non-condensing boiler to a condensing alternative, which resulted in a 25% saving of £1,600 per annum. With a capital contribution from the Green Business Fund, it resulted in a payback period of just 2.5 years for this particular system. And for air conditioning controls, this adhesive manufacturing company in Sussex, down south, had to maintain the internal temperature for its for rooms essentially, and clean rooms that were essential, had critical temperatures for the part of its manufacturing process, multiple split systems cooling multiple rooms, all on independent control. So many were running out of hours, many were overcooling. So the installation of a supervisory controller resulted in annual savings of over £4,600 per year, with a projected payback of 1.6 years. With capital contribution from the Green Business Fund, this payback was reduced to 1.1 years, and that's just with effective control of their air conditioning systems. So I'll give you a quick run through of the Green Business Fund. So it's a scheme operated by the Carbon Trust to contribute to improve sustainability and energy efficiency. It currently serves small to medium-sized businesses in England, Scotland and Wales, 2016-17, and will be going into 2018. The fund today provides a combination of advice, training and direct contribution to capital equipment. There is scope for the fund to expand both UK and internationally, and should additional funding be made available, then suitable body for that purpose. You can get more information on that via the Green Business Fund website. It's just important to note that this is very much while funds are available. It's currently predicted to run into 2018, but we're really looking at the most cost-effective, high-quality energy reduction solutions available for customers. And if you haven't yet taken action, then it's a finite pot. It's first come, first serve. So I'd encourage you to engage with the Green Business Fund as soon as possible. Eligibility. Where is it currently available? So it's available in England, Scotland, and Wales. Who is eligible for the service? SMEs, schools, sole traders, charities. They can all be supported by the Green Business Fund. Domestic properties, public sector, and new builds can't. We can assist with refurbishments, but only for energy-saving initiatives. So if you're upgrading your boiler with your refurbishment, that can be supported. We won't pay for your painter. And how do we define? This gives a bit of a description here as to how we define an SME. So no more than 250 employees. There are restrictions on annual turnover and annual balance, and you're not more than 25% owned by an entity which does not meet the above criteria. The services we can offer through the Green Business Fund, we run energy efficiency training. We hold these around the country. They're 2-hour workshops hosted by a Carbon Trust partner but delivered by a Carbon Trust expert, helping you understand your energy consumption and identify low cost, no cost energy savings for companies with less than 50 employees. And we have some upcoming dates in the Southwest and Blackpool and Sittingbourne over the following weeks. So if you are local to any of those, I'd encourage you to go along and learn a bit more about energy saving. As mentioned during this presentation, you can also avail of a funded opportunity assessment, which is a bit like an energy audit, which will take place remotely or on site, where someone, a Carbon Trust engineer, will come to site and provide you with recommendations on how to save energy, and provide you with a tailored appraisal of how to go about implementing your energy efficiency on your site most effectively, with costed recommendations and guidance on how to go about actually implementing those recommendations once they've been made. A case study here of a local business that availed of this service and helped identify energy savings up to £12,000 annually with a payback period under 3 years. So having that engineer and detailed insight on your operations is really worthwhile. Another part of the service is how to go about taking these recommendations forward, which is our implementation advice. So it's for those who have an energy efficiency investment opportunity but don't know how to take it forward. We're able to give you impartial expert advice and confidence to invest. We'll guide you through the tender process. We'll help you with putting together specifications and invitation to tender packs. We'll shortlist credible accredited suppliers, and then we'll provide you with an independent review of the resulting proposal. So really provide you with support through the whole tender process. This is the only service that's aimed at non-large organisations, so up to 1,000 people. The aim of this being that we're able to support some businesses that were part of the Energy Saving Opportunity Scheme, ESOS, and help them implement some of the recommendations that were made during that process that took place in 2015. But this is really to help you with this whole procurement of the energy efficiency solution. And lastly, for the Green Business Fund, we have capital contribution. This is non-refundable capital contribution of 15% for your projects with a payback of less than 5 years. It's a straightforward process with a quotation from our accredited supplier. The 5-year requirement, we do support projects with longer paybacks than 5 years, but the contribution will be scaled based on the energy savings that are achieved by the project. We'll provide financial verification, identity checks will be carried out, and we'll provide a technical assessment to confirm the project particulars, and that will be undertaken by one of our technical engineers. But ultimately, it's a capital contribution to help you make these energy efficiency investments. Other schemes with the green, apart from the Green Business Fund, that we support are the interest-free efficiency loans. designed to support businesses in upgrading to more efficient equipment and renewables. This is a list of the technologies. These are building technologies, so HVAC systems, as we've discussed today, industrial process technologies, and renewables. These are only available in Wales and Northern Ireland, so Welsh SMEs can borrow 3,000 to 200,000, and in Northern Ireland, businesses of all sizes can borrow. And the loan offer is based on CO2 savings a project can deliver, so £1,000 for every 1.5 tonnes of CO2 saved annually. A bit more on the loans. They're designed so that in most cases monthly repayment will amount to similar to reduction in the customer's monthly energy bill. They're sense checked by engineers to provide assurance that they can be achieved, and they're interest-free, unsecured, with no setup fees. Businesses in Wales can apply for the Green Business Fund as well as the interest-free loan. So the Green Business Fund can support up to £5,000 of the total project cost, and the interest-free loan could support the rest. And if you want more details on our loans, then information is provided on these links on our website, or you can email our loans team with the details at the bottom. I did mention this during the presentation, the energy technology list. It's essentially a directory of energy efficiency products that if purchased, an organisations that pay income tax or corporation tax can claim enhanced capital allowance or ECAs on the purchase of the equipment, which means you can get all of the tax benefit in the year of purchase. So an organisation spending £10,000 on ETL equipment could benefit by £2,000 a year. And that brings us to the end of the information that we were looking to provide in this presentation. So I'll have a look through and see if there are any questions that have come in during the process. Okay, so we have a few questions. I'll go through these. So, how advisable is it to install air conditioning units near glass windows? Well, often the air conditioning unit itself won't be sensing temperature. So, one thing I would suggest is that the thermostatic control is located away from direct sunlight. You may find that as it's blowing out air, it mist or fog the window, so that's one consideration. Ideally, yes, you would locate it further away from windows in an area where it is really affecting the ambient temperature. You can often get varying temperatures near windows based on the amount of daylight coming in. If it is direct sunlight, it does depend on the exact orientation that you have within the space, but if you can install it further away, then that would be advisable. I have another question from Hassan. Do you recommend conducting extensive HVAC studies for commercial offices where only air conditioning is required, or a rule of thumb kind of formula is good enough for such locations? If you can and have time and capability, then I would go into as much detail as you can with the study in order to realise effective energy savings. I think the rule of thumb guidance, some of which we've given through this presentation, is useful for guiding your thought process. But if you're looking to really look at how to drill down and identify the energy savings, then I would really look more closely via an energy audit, via an opportunity assessment through the Green Business Fund at the operation of your HVAC systems, and really engage with your maintenance staff.